Good morning, everyone. My name is Navina, and I am an assistant professor in mathematics at AVN Institute of Engineering and Technology. Today, we are going to discuss about introduction to probability. So now we'll see what is probability and how do we use probability in real life. Most people use terms such as chance, likelihood, or probability to reflect the level of uncertainty about some issues or events. For example, as you watch news every day, you hear forecasters saying that there is a 70% chance of rain tomorrow. If we see another example, as you plan to enter any business, an expert in that particular field tells that the probability of making a first year profit in this business is only zero point 0.4 or 40% chance. As you take a new course, you may be wondering about the likelihood of passing or failing the course. So, all these are the probabilities that we come across in our day to day life. So, what is probability? A chance of happening an event is called probability. Let us consider A is an event, then P of A equals to M by N, where M denotes number of favorable outcomes, N denotes total number of outcomes. The probability value lies between 0 and 1, that is, 0 is less than or equals to P of A is less than or equals to 1. From this, we can say that if the probability is equals to 0 or close to 0, it implies that an event is very improbable to occur. Or if the value of probability is 1 or close to 1, it gives us higher assurance that an event will occur. For example, if we take that the chance of winning is 0 0.2. As we see, 0 0.2 is very close to 0. This implies that this event is very impossible to occur. Or else, if they say that the chance of winning is 0 0.9, as we see, 0 0.9 is very close to 1. So, it gives us higher assurance that an event will occur. So now we'll see some basic definitions in probability. And the first one is random experiment. So what is a random experiment? An experiment that can be repeated any number of times under the same conditions is called random experiment. For example, tossing a coin or rolling a dice. As we see, when we toss a coin, it has only two faces. So when we toss a coin, we'll get either head or tail. So when we repeat this experiment any number of times under the same conditions, we see it has only two conditions, we'll get either head or tail. So we'll get either head or tail. An experiment which can be repeated any number of times, such type of experiments are called as random experiment. Or rolling a dice, we can see the dice has 6 faces. So when we throw the dice, we'll get either 1, 2, 3, 4, 5, 6. We'll get any one of these numbers. So this experiment which is repeated under any number of times, that such type of experiments are called as random experiments. And now see the next definition, sample space. So what is a sample space? A set of all possible outcomes of a random experiment is called a sample space. Set of all possible outcomes of a random experiment. Now, as we see, tossing a coin is a random experiment. So, what are the possible outcomes when we toss a coin? We get either head or tail. So, the sample space S is equals to head and tail. And when we roll a dice, what are the possible outcomes? 1, 2, 3, 4, 5, 6. So the sample space S is equals to 1, 2, 3, 4, 5 and so on 6. So this is about sample space. And see the next definition. The next definition is event. So what is an event? Each element of a sample space is called an event. In other words, we can say that An event is a subset of a sample space. Each element of a sample space. If we take sample space when we throw a dice, what is the sample space when we throw a dice? 1, 2, 3, 4, 5 and 6. So each element, 1 is an event, 2 is an event, 3 is an event and so on till 6. Each element is an event. When we toss a coin, what is the sample space we get? Head and tail. So head is an event and tail is another event. Let us see an example. So in rolling a dice, so what is an experiment? What is a sample space? And what is an event? We know that rolling a dice is an experiment. So in rolling a dice, the experiment is nothing but rolling a dice. The next question is, what is a sample space? We know that sample space is nothing but set of all possible outcomes of a random experiment. So now the experiment here is rolling a dice. So when we roll a dice, what are the possible outcomes? 1, 2, 3, 4, 5 and 6. So the sample space S is equals to 1, 2, 3, 4, 5 and 6. Now what is an event? We know that event is nothing but every element in a sample space is called as an event, or we also say that an event is subset of sample space. If they ask you to find the probability of finding an even numbers, so what are the even numbers here? 2, 4 and 6. If they ask you find the probability of finding odd numbers, so what are the odd numbers in this example? 1, 3 and 5. So this is about what is a random experiment, sample space and event. Now coming to the next definition, mutually exclusive or disjoint events. So what are mutually exclusive events? We can also call them as disjoint events. Two events are said to be mutually exclusive or disjoint if they cannot occur at the same time. In other words, we can say that when the happening of one event excludes the happening of other event, then we call such events as mutually exclusive or disjoint events. Disjoint events are nothing but if the intersection value between two events is equals to 5, then we call such events as disjoint events. That is, probability of A intersection B is equals to 5, which is equals to null set. For example, in tossing a coin, head and tail are mutually exclusive. How can we say that head and tail are mutually exclusive? As I said, mutually exclusive events means when two events cannot occur at the same time. So when we toss a coin, we'll get either head or tail. Is it possible to get head and tail at a time when we toss a coin? No. When we toss a coin, either we get head or tail. It is not possible to get both head and tail at a time. So such events are called as mutually exclusive events. So as we see here, on tossing a coin, head and tail cannot occur at the same time. So these events are called as mutually exclusive events. Even when we roll a dice, we'll get either 1 or 2 or 3 or 4 or 5, 6. Is it possible to get 1 to 6 numbers all at a time when we roll a dice? No. So rolling a dice is also a mutually exclusive event. So now we see mutually inclusive events or non-mutually exclusive events. So what are mutually inclusive events? So two events are said to be mutually inclusive if they occur simultaneously in a single trial. Or in other words, we can simply say that when there is something common in between two events. When there is something common in between two events, such events are called as mutually inclusive events. For example, let us take A is an event consisting of numbers 2, 4 and 6, and we take B as another event consisting of numbers 1, 2. Now can you see, is there any common point between these two? Yes, 2 is a common number between these two events. That is, probability of A intersection B is equals to 2. So these type of events are called as mutually inclusive events. That is, when there is something common in between two events, we call such events as mutually inclusive or non-mutually exclusive events. Now we'll see addition rule. So addition is nothing but it represents union or plus. All these three terms represents addition rule. So how will you use addition rule for mutually exclusive events and for mutually inclusive events? So when it comes to mutually exclusive events, the addition rule is P of A or B equals to P of A plus P of B. So when it comes to mutually inclusive events, the addition rule is P of A union B is equals to P of A plus P of B minus P of A intersection B. So how will you identify whether the given question is mutually exclusive or inclusive, and which addition rule we are going to use? So we'll see in the next example. So coming to the next example. So now we'll see the example. What is the probability that a card drawn at random from the pack of playing cards may be either a queen or king? So now first we'll see whether it is an example of addition rule or multiplication rule. As we see in the question, it is given that either a queen or king. So R represents, I have told you already, addition means it represents R union or plus. If you find all these symbols, then it comes under addition rule. So we have to find probability of either a queen or king. So R represents addition rule. So now it is clear that we have to use addition rule. And the next question arises is whether we have to use mutually exclusive or for mutually inclusive. So first to see the question, what is the probability that a card drawn at random from a pack of playing cards? So we know that how many total number of playing cards are 52. So the sample space n of s is equals to 52. So now what we have to find? We have to find the probability of getting either a queen or king. So now let us consider E1 be the event of getting a queen card. So we know that in total 52 cards we have 4 queen cards, that is 4C1 which is equals to 4. And let us take E2. E2 be the event of drawing a king card. So we know that in total 52 cards we have 4 king cards, that is 4C1 which is equals to 4. Now we have to see whether they are mutually exclusive or inclusive. So how will you find? If there is nothing common between the two, then we can call them as mutually exclusive. If there is something common between the two events, then we can call them as mutually inclusive events. Now see the events. What are the events here? E1 and E2. So if we see E1, E1 is nothing but event of drawing a queen card, and E2 is nothing but event of drawing king card. So is there any common point between these two? No, because queen cards are different, king cards are different. So the probability of E1 intersection E2 is equals to 5, which is null set. So we can say that E1 and E2 are mutually exclusive events. So from addition rule for mutually exclusive events, P of E1 union E2 equals to P of E1 plus P of E2. So P of E1 is nothing but total number of number of outcomes by total number of outcomes. So what are the possible outcomes? 4 by total number of outcomes is 52. So 4 by 52 plus P of E2 is nothing but n of E2 by n of s, that is 4 by 52, which is equals to 2 by 13. This is about mutually example on mutually exclusive and inclusive events. So now we have seen an example for mutually exclusive, and we'll see another example for mutually inclusive events. So see the example. A card is drawn at random from a well shuffled pack of cards. What is the probability that it is either a spade or an ace? So clearly it is representing R, so it comes under addition rule. So now we have to find whether it is mutually exclusive or inclusive. So again it is from a pack of cards, we have to choose a card. So the total number of cards are 52. So the sample space n of s is equals to 52. Let us take two events where A denotes event of getting a spade and B denotes event of getting an ace card. So now we have to find is there anything common point between A and B. As we all know, we have total 13 spade cards in which we'll have one ace card. And again here we have B denotes an ace card. So what is there any common point? Yes. In spades we'll have one ace card and B also denotes ace. So if we take the sample space for event A, it will be numbers from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, one ace card, king, queen, cards. So when A for B is an ace card. So ace card is common between both A and B events. So probability of A intersection B is equals to 1 by 52. Let us say that A union B denotes event of getting spade or an ace card. A intersection B denotes event of getting spade and an ace card. So now the probability of A is given by what is A denotes event of getting spades. So total we have 32 spade cards, that is 32 C1 by 52 C1. Now we will find probability of B. Probability of B is nothing but probability of getting an ace cards. So total how many ace cards we have? We have 4 ace cards and we have to choose one. That is 4 C1 by 52 C1, which is equals to 4 by 52. Next, probability of A intersection B. Yes, in spade card we'll have one ace card and here we have another ace card. So what is the common here? Ace card is common. So probability of A intersection B is equals to 1 by 52. So now we can see, we know that if there is something common point between the two events, such events are called as mutually inclusive events. So probability of A union B is equals to probability of A plus probability of B minus probability of A intersection B, that is 13 by 52 plus 4 by 52 minus 1 by 52, which is equals to 4 by 13. Our next topic is independent events. When do we say two events are independent? Two events are said to be independent if the occurrence of one event does not affect the occurrence of another event. For example, find the probability of getting head and tail when two coins are tossed. Here head is event 1 and tail is event 2. So when two coins are tossed, we know that in a coin both head and tail will have equal chances, that is 1 by 2 and 1 by 2. Now probability of getting head is 1 by 2 and probability of getting tail is 1 by 2. So here probability of getting head is event 1 and probability of getting tail is event 2. So we see here what is the definition? If the occurrence of one event does not affect the occurrence of another event, that is probability of getting head is 1 by 2. When this event has happened, it does not have shown any effect on the other event, which is probability of getting tail. Now see the next example. When two pack of cards are drawn, what is the probability of getting ace and king card? So what is here getting an ace card is event 1 and getting a king card is event 2. Now we have to find whether is there any effect on event 2 when event 1 has occurred. So what is the probability of probability of getting ace cards? It is 4 by 52 and probability of getting king cards is 4 by 52. As we see, there is no effect on event 2 after event 1 has been occurred. Now see the next example. Let us see the third example. A bag contains 4 white balls and 3 black balls. A bag is containing 4 white and 3 black balls. A ball is chosen at random. Find the probability of getting 2 white balls. Chosen at random, that means taking the ball one after the other. So we have to find the probability of getting 2 white balls with replacement. So now we can see how many number of balls in total we have. 4 white plus 3 black, that is 7 balls. So total number of balls are 7. So now what we want? We want probability of getting 2 white balls when a ball is chosen at random. That means we have to pick one after the other. So first I have chosen a white ball. So how many white balls we have? 4. So 4 C1 by 7 C1, that is 4 by 7 into again I need white ball. So we know it is replacement. So when I have taken the ball, another ball is replaced in that place. So again it will be 4 white balls, that is 4 C1 by 7 C1, that is probability of getting 2 white balls is equals to 4 by 7 into 4 by 7 when the ball is replaced. So this is about independent event. Coming to the next definition, dependent events. When do we say two events are said to be dependent? Two events are said to be dependent if the occurrence of one affects the occurrence of other. So now let us take an example. A bag containing 4 white balls and 3 black balls is chosen. We have to choose a ball at random and find the probability of getting 2 white balls. A ball is taken at random. That means we have to take one after the other and we have to find the probability of getting 2 white balls without replacement. That is, when the ball is picked up, the ball is not replaced again. So now we have to find the probability of getting 2 white balls. So total how many number of balls we have here? We have 4 white and 3 black, together consist of 7 balls. So first I have taken one ball. So I have to choose one ball among 4 white balls, that is 4 C1 by 7 C1 into I need 2 white balls. So now again I have to choose one more white balls. So already I have taken one white ball. So how many balls will be remained there? It will have 3 white balls. Why? Because it is without replacement. In previous example we have seen it is replaced. When a ball is chosen, another ball is replaced. Here it is without replacement. So among 4 white balls I have already chosen one white ball. So the remaining leftover are 3 balls. So 3 C1 by total are 7 and I have already chosen one white balls. So the remaining balls are 6. So 3 C1 by 6 C1, which is equals to 3 by 6. Can you see the difference here? What is event 1? Event 1 is choosing a white ball and event 2 is also choosing a white ball in the second draw. Event 1 is choosing a white ball in the first draw and event 2 is choosing a white ball in the second draw. So when event 1 has occurred, there is a change in event 2. As we have chosen one ball, the number of balls have been reduced. That means when event 1 is occurred, there is a change, there is an effect in event 2. These type of events are called as dependent events. Now we'll come to multiplication rule. So multiplication represents intersection and multiplication symbol. So how does multiplication rule varies for independent events and dependent events? Now see the multiplication rule for independent events. If A and B are two independent events, then the probability of the simultaneous occurrence of A and B is equals to the product of their individual probabilities. That is, P of probability of A intersection B is equals to probability of A into probability of B. When it comes for dependent events, if A and B are two dependent events, then the probability of simultaneous occurrence of A and B is equals to the probability of one event multiplied by the conditional probability of other event. That is, probability of A intersection B is equals to probability of A into probability of B by A. So this is the multiplication rule for independent events and dependent events. We'll see another example where we'll identify whether it is addition rule or multiplication rule, and if it is multiplication we have to go either for independent or dependent. We'll see in the coming example. Coming to the example, find the probability of drawing 2 red balls in succession from a bag containing 4 red and 5 black balls. When the ball that is drawn first is, we have two questions here, not replaced and replaced. So we have to find what we have to find probability of getting 2 red balls. So total we have a bag is containing 4 red and 5 black balls. So the total number of balls is equals to 9. So what we have to find probability of getting 2 red balls. First question is probability of getting 2 red balls when the ball is not replaced. So let us take E1 be the event of drawing red ball in the first draw and E2 be the event of drawing a red ball in the second draw. So total how many balls we have? 9. In 9 total number of red balls are 4. So first we choose probability of event, that is event of drawing red ball in the first draw, that is 4c1 by 9c1 which is equals to 4 by 9. Now see E2. E2 is nothing but event of drawing red ball in the second draw. So probability of E2 is equals to, since the balls are not replaced, so out of 4 red balls I have already chosen 1 red balls. So the remaining red balls are 3, that is 3c1 by total number we have 9. Out of 9 I have already taken 1, so the remaining are 8. So 3c1 by 8c1 which is equals to 3 by 8. Now we can say it is either dependent or independent. It is dependent event, because when event 1 has occurred there is change in event 2. When event 1 is occurred, it affects the event 2. Then probability of E1 intersection E2 is equals to probability of E1 into probability of E2 by E1 which is equals to 4 by 9 into 3 by 8 which is equals to 1 by 6. And the second question is replaced. When the ball is replaced, find the probability of getting 2 red balls when the ball is replaced. So what is probability of even? Even is nothing but drawing a red ball in the first draw. So total red balls are 4, that is 4c1 by 9c1. Since the ball is replaced, already I have 4 out of 4 red balls I have chosen 1 and the ball is replaced, so again 4 will be left over. So probability of E2 by E2 equals to 4 by 9. So this is an example of independent events, because when event 1 is occurred there is no change in event 2. So the probability of E1 intersection E2 is equals to probability of E1 into E2 which is equals to 4 by 9 into 4 by 9, that is equals to 16 by 81. Thank you.